Hello everyone, in this video we will walk through the process of managing your VNF with the Helm Execution Environment. OSM's execution environments provide a runtime framework to run primitives. These execution environments provide a means for network function-specific management code to run into a dedicated Helm chart. OSM communicates with its execution environment to trigger actions via gRPC calls, which are handled by a front-end component, running in a pod, in its constituent Helm chart. The Helm chart can contain, for example, Ansible playbooks that simplify the VNF configuration. Our goal is for you to understand and create a Helm chart that OSM can interact with, create your own Ansible playbooks to perform both day 1 and day 2 operations, and understand how VNF descriptors can refer to your Helm chart and Ansible playbooks. Firstly, let's start by downloading Helm and Ansible, running the following code. Regarding the gRPC image, the code used in this tutorial has been adapted from OSM's. Thus, you should build a Docker image and push it to your images registry. If its code is not up to date with protocol buffers, to regenerate the protocol buffers, do the following. Download and install the Python compiler from protobuf, following the instructions in the README file, and delete both these files. All your Ansible playbooks must be present in your Helm chart inside the source folder. The goal of the day 1 primitive is to create an empty file on the VNF, edit the playbook file and add the following content. The update file playbook will be invoked on the day 2 primitive. This primitive will update the file's content with the user input. For that to happen, first, you need to edit the update file and add the following content. Now we need to change the Helm chart manifests. Inside the Helm chart you may find the file values.yaml, which will be used to change variable values, such as the image names used. Edit the values file and add the values in the image block to match your registry's image. Concerning image registries, in OSM 14 the Helm charts are deployed in the namespace created on the fly. However, we cannot share secrets across namespaces. One solution can be to include the image pool secret inside the Helm chart. Edit the values file and add the correct Docker config to access your registry. Now we'll need to change the VNF descriptor to reference the Helm chart. A pre-requirement to define execution environment-based primitives is including the appropriate reference in the descriptor to the own execution environment. Edit this file and inside the df element add the following block. To avoid later errors on OSM, we can right away lint the Helm chart after the new changes made. Now, we can include the day 1 primitive block referencing the playbook.yaml file. Inside the initial config primitive block, add the following content. One thing to notice is that the parameters value must match the playbook's file name. Now, we can add the reference to the day 2 primitive. The primitive requires two parameters, the playbook file name and the content to be added to the file created in the day 1 operation. Make sure to add the following block code below the initial config primitive directive. Next, we need to instantiate the network service. This can be done directly on OSM or using its CLI. Now, we can check if the day 1 operation was successful. We can do this by entering our machine and seeing if the file was created. Now we can perform the day 2 operation as explained in the tutorial. One thing to make sure is to match the playbook name's parameter value to the Ansible playbook file name. Finally, we can check the file content to see if it was updated.